I love science. I love finding out new things. Discovering and research is really a big driver. Seeing people learn and see a concept and just get that, the wow factor is incredible. Students that we educate, grow and develop in their careers, really is a key motivator. I'm Steve Hilton. I'm an Associate Professor at UCL School of Pharmacy. A lot of our work at the School of Pharmacy focuses on drug discovery, developing molecules that have anti-cancer properties, antiviral properties, or also look at memory disorders. So we have the ability to have patients at our core and our target for our focus. So all of our innovations really are focused on patient benefit. Within my team, the background or the fundamental of all projects is chemistry, and then aligned to different disciplines. So some are more focused on the applications of 3D printing, which is a big focus of our work, looking at how do we make chemistry simpler and more efficient. Other areas focus on flow chemistry, so where we can actually look at new ways of making molecules and scaling those up for production, and others on technology. And the applications of chemistry within that as well, and more recently into virtual reality and how to enhance the student experience and training.
My name is Irene Gironacci and I manage projects about virtual reality, augmented reality, artificial intelligence and 3D simulators at Agilent. Academia now has a big challenge that they have a few instruments and they have a lot of students. And having virtual reality can enable academia to have a certain amount of instruments so they can train more students using the systems. Hiltonlab has digital twins, so students can learn from real data.
The equity for access is really key. We want our students to be the best trained that we can do. Using VR, we've been able to digitize equipment, so Agilent HPLCs and other systems, and apply those into the virtual world, giving our students training which is commensurate with the best in the world.
My name is May Taylor and I'm a third year PhD student at UCL. I feel like we're in a very inspiring environment here in London and especially here in Steve Hilton's group at UCL. Constantly coming up with new ideas and new ways to utilise technology. So it's constantly innovation and creativity, and marrying that with kind of scientific research is really exciting.
So with the Agilent HPLC systems that we developed in virtual reality, we have the ability to work in exactly the same way as real life. You can degas the system, you can add columns, you can change the columns, you can load the solvents on top. You can then also open the doors. You can load samples the same way you can in real life, into the trays, into the right position, and the robotic arm moves and then transmits that into the system as well. You can see the run from there as well.
Plus, if you combine it with some core technologies like artificial intelligence and digital twin, you can have AI avatars talking to you, maybe using ChatGPT or Copilot, and train you basically like real trainers.
What kind of compounds are you analyzing?
So you will be able to have a realistic training experience.
Having the ability to incorporate the Infinity 3 system into our virtual reality software is a big change for our students. They will be trained on current systems that they will work in on industry.
Agilent will increase its use of VR capabilities, absolutely, this is the future. And in a few years from now we can envision that a lot of trainees will be trained on VR because it's cost effective. Is risk-free and you can train everyone everywhere, and we can ensure that we have key knowledge transferred to students, and in general the world is changing, so we really want to shape the next generation of scientists here.
We never want to be stopped by the boundaries that we have. We want to be only limited by our imagination in science. You have an idea, you can do anything with that using 3D printing and virtual reality.